all you Greta's and Chutescots out there, it's math time. So we are in Unit 3, Section 4. We're going to look at some population math. So we are on page 16 of your packets. Crude birth rate is also abbreviated CBR. That's usually how you'll see it in test questions. And this is the number of births per 1,000 individuals per year. And I can tell you right now, sometimes they will give you this many births happened in 4,000 individuals. So you'll need to do the math to get it down to that 1,000 individuals per year. So just something to keep in mind. Crude death rate is CDR, and that is the number of deaths per 1,000 individuals per year. So how many people born, how many people die. Population density is the population in a specific area, which means if they're asking for the density, you need to give the number of people and the unit area. So the national growth rate is the birth rate plus immigration minus the death rate plus emigration. So how much we've increased minus how much we've decreased, and you divide that by 10. So the global growth rate is similar. They can also call that the rate of natural increase, and they don't care about immigration or emigration because not too many people are entering or leaving this planet. So it's just birth rate over death minus death rate over 10. An equation I may memorize. The big one that I would definitely memorize, you need to use very, very few equations on the exams, but this is one you're going to want to know. The rule of 70. Doubling time in years is 70 over the growth rate in the percentage. This is the only time this happens. So if the growth rate is 10, you put down 10. You don't put down 0.1. You literally put it in the percentage. So it's silly and weird, but it's how it works. So if you want to find a future population from growth rate, most of the math that you will see on a test will be this. They'll ask for the doubling time or they'll ask for the growth rate, and they'll give you the opposite. This is the main one that you will see. But for finding future populations from that growth rate, you take your initial population times the growth rate, 2 years, and that's your final population. So growth rate of 3% is expressed as 1.03. A growth rate of 0.25% is 1.0025. For example, you would have this many people in growing at a 3% growth rate over 10 years is that many people. So in your packets, you've got some math. I'd like to see you guys attempt those on your own. That is a homework assignment, so I'm not going to go through the answers now. But see what you can do with those. Feel free to hit me up after school, iPass, Wednesdays, or just through email, and I can help you as you need to. But all you need to know is right here to get that math done. So there's your math part. Now we're going to go on. So if you flip a couple pages ahead to page 19, you'll see total fertility rate. This is the average number of children a woman produces in a population throughout her life. Hopefully you're not having 20 children like the Duggars. That is insane. So here we have US is 1.8. We're actually less than 2. Our population is continuing to grow because of immigration. So immigrants are literally making America great again, because this way our population is still growing and we have enough people in the workforce. World is 2.4. Niger is 7.2 and South Korea is 1.1. So their population is actually decreasing. Niger's is definitely still going up. So you can see areas where 6 to 7 kids a woman. That's crazy. So you can see where we don't have any 0 to 1. That's awesome. But we do have definitely a bunch of 1 to 2s. You want to be two babies per woman, because that replaces you and your mate to maintain the population. World's smallest family. South Korea has the lowest fertility rate in the world with an average of 1.1 child each. So once again, replacement level is 2.1 children per woman, and that takes into account infant mortality. So you can see the differences there and how fertility rate has changed over the years. Alrighty, so replacement level fertility. This is the total fertility rate required to offset the average number of deaths in a population to keep the population size stable. So you need to have enough people to work, to take care of everything. This is your replacement level fertility, which is, like I said, just over 2. In developed countries, the replacement level is about 2 due to high levels of industrialization and income. We tend not to lose too many of our babies in that first couple of years. Developing countries, it's 2.2 or higher due to high levels of infant and child mortality. And that's why they tend to have more babies. And then if they lose 1 or 2, they at least have a couple left. My family in 100 years, I'm going to go ahead and just give you all of these things. There is an activity, but I'm going to just give you the answers. So you might recognize some of these names. So here's the generation tab. This means how old you are when you're having your first kid, number of children born each generation by per every 100 years. So if the Targaryens start having kids at the time they're at 15 and they have 2, in 100 years, the Targaryen family will have 6.7 generations in that 100 years, and that will give them about 104 offspring. The Nope family waits till they're 25, but they still have 2 kids, so that's 4 generations in 100 years, and only 16 kids. So you can see if you wait a little bit, much fewer children. So here I will let you write down all of these things. But you can definitely see if you're waiting later to have a kid, you're going to have much fewer kids. So these top 3 all had 2 kids, but they waited different times. And you can see how many offspring that would result in after 100 years. These 3 all had 3 kids, and you can see the numbers are going down. And these last 3 had 4 kids apiece, but they're definitely, these starting earlier makes a much larger impact than more kids. Slightly, going from 7 to 24 kids to 56 kids is definitely an increase, but not like 104 to 1573 to over 10,000 children. Don't do this, guys. All right, so which has a greater impact? The number of children in each generation or the time? Time between is definitely the most. So there we go. There's a neat article. It's in the New York Times, and the link is also in your packet. There's also an interactive activity, computer interactive. Feel free to do that if you want. It is not mandatory. I'm not collecting on that. It will just kind of help you understand things a little bit better if this is something that confuses you. There's another article about China ending the one-child policy, allowing families to have 2 kids. Because they've really messed up their population over there. This sex ratio is very, very messed up when you can only have 1 kid and most people prefer males. So that takes you onto page 22, and then we're going to talk about life expectancy. So who do you think lives longer, males or females? We win. We tend to live longer. So even though males are living longer than they used to, we are as well. So both are increasing. So why do you think the females are living longer? There are a lot of gender-specific diseases out there where men get affected more than women do. Even COVID is affecting males more than females. Hazardous lifestyle choices tend to be higher in males, so then you're exposed to more stress, physical stress in your life, which might shorten your life. Wars, once again, males are typically who are going off and fighting those, and they tend to have more dangerous jobs. So all of those things will allow females to live a little bit longer than males. So here's your life expectancy at birth, and this is crazy. So this is less than 45 to the 50s versus over here we're in the 70s, and then there's a couple of places where we're up in the 80s. So it's really interesting that just where you're born can have, and the lifestyle and the culture that you're exposed to can change your life expectancy so much. I just think that's amazing. So here's one for infant mortality. And so you can see where, and this is once again per 1,000, You can see where it's lower, you can see where it's higher, you can see where it's really bad. Once again, you can probably put some correlations to those. So what are factors that affect life expectancy? Infant mortality rate and child mortality rate in a country. So we have things like available health care or prenatal care, adequate food supply, potable drinking water, good sanitation, moderate to low levels of pollution are all things that will affect those. So there you go. Moving on. We're looking at age structures and pyramids. So I want to go back and just make sure I've addressed that. So infant mortality rate is the number of deaths of children that are less than a year old per 1,000, and then child mortality rate is from 0 to 5 years old, or sorry, from 1 to 5 per 1,000 births. So I want to make sure you guys have that, and then all of those things. Moving on, click. So we have our age structure pyramids, and these are going to display the number of individuals within specific age groups or cohorts for a country, and they're divided by gender. So you have a male side and a female side, and then all of the, and we looked at this before a little bit, and then the ages. So there we go. So let's look at a couple, because I think this is kind of cool. What historical events and trends have led to our current U.S. population pyramid? So here we have the end of World War II. So you can see there was definitely a decrease of population, males and females before. Here's your baby boom. Here is the 60s and 70s, a little bit of a time of unrest. Here we have baby boomlet, or the millennials. So millennials get their own little bump. So that's some cool things that are affecting the U.S. population. Now let's see if you guys can guess on some other things. Anybody want to guess what's going on here? Way too many males, not a lot of females. This is in the Middle East, when males are needed to work in the oil fields and oil rigs and all that fun stuff. There's a lot of jobs available, so men will go to those countries to do those jobs. There's a couple women there as well. All right, so somewhere in Pennsylvania, we've got this huge group here, right here, 20 to 24. Any guesses on what might have caused that to happen? This is actually the county where Penn State is found. So this is a college town, which would make sense when that is a huge, huge aspect of their population pyramid. Ooh, it looks like a bird. Now we're in Colorado. And if you look, most of the population is up here, and this is actually a retirement community. So it's kind of neat to see how these things happen. And what do we got over here? Kentucky, way too many men in the 20 to 24 range. This would be a military base. So you can learn a lot when you're looking at population pyramids, when you've got, especially if you've got something funky going on. All right, so there's a GIF. I will put the link on Canvas. We're not going to look through it now. Pyramid project, we are skipping. There is an article as well that, once again, if you would like to read, feel free. It'll just help you understand stuff just that much greater, especially if this is something that is struggling for you, if you've not gone through human geo before. And we have finished notes. So before I go, I want to just let each and every one of you know that you are good enough, you are smart enough, and people do like you. And if I don't see you, good afternoon, good evening, and good God, do your